Who's coming? Oh, yeah, Drew's absent. So he is absent, but I remember he's absent, so. All right, so remember when we do long division, we're just going to rewrite. All right, and then we take the first term. We take the first term into the first term. And if you have trouble doing that, then you rewrite it off to the side. 3x cubed divided by x. That cancels out one of those x's, and we get 3x squared. Then what do? Distribute. So we divide. I'm just going to write this somewhere here. We divide, then we distribute. So we're going to distribute that to both terms. And we get 3x cubed. And then when I multiply by -1, I get minus 3x squared. What do we do next? Oh, excellent. That sounds so nice. Draw the line, change all the signs. And then what do we do after we draw the line, change the signs? We add, right? So we add them up and we get negative 4x squared. A lot of us had positive there. I know. No, I'm saying that because I was thinking about you guys doing that. A lot of us made that silly mistake. And what happens if you do? What happens if you do make a silly mistake like way early? No, so unfortunate. So we definitely want to try our best to make the least silly mistakes as possible. Here we go. From here we take x into negative 4x squared. So at that point we repeat the process. Well, I guess I didn't say it out loud. I did it. We drop down the number, drop down the next term, then we repeat the process. So we repeat the process. X goes into negative 4x squared minus 4x times. We distribute negative 4x squared plus 4x. We draw the line, change both signs. And we get 2x. Then we drop down. We repeat the process. X goes into 2x 2 times. Distribute. 2x minus 2. Draw the line, change the signs, and we get 10. And then once you don't have any more numbers to drop down, then you're done. So our answer, 3x squared minus 4x plus 2. Then we have to put a plus, and then how do we write our remainder? Right, it's the divisor, x minus 1, the divisor. We put it over whatever we were dividing by, right? Excellent. So what if I told you there was like a way easier, faster way of doing that? Say, sign me up. So what we're doing today is we're going to learn a process called synthetic division. And synthetic division is a way faster, easier way of doing what we just did. It is. However, synthetic division doesn't always work. So it only works in special cases. If we do have those special cases, we can use the shortcut. If we don't have the special case, we have to do long division. So you do have to know long division. The notes that we did last time, most of those you had to do by long division. When you can use synthetic division, I know this is a lot of words, we don't have to read all this right now. When you can use synthetic division is if we have what we are dividing by in the form of x minus a number, x minus k. If what we are dividing by is in that form, x minus k, then we can do synthetic division. Now, I will show you the x minus k each time that we do the examples so you start understanding what that form is. Basically, there's an x by itself, no squared, no number in front of it, and then we've got another number with it. That's it. that x is by itself. So when you did your homework and when you did your assignment, like Allison wasn't here when we took notes when I was helping her with it earlier. The first thing that she was dividing by was like x squared. She could not use symbolic coefficient. All of these steps are here, so if you forget what to do, you can go read it. I'm not going to read this for you. I'm just going to do the steps. But they're all written there for you, just in case you forget what they are. All right, you ready for this? Okay, so what we are dividing by in this case, is x minus 3. And that is in the form of x minus k. We see that that is in the form of x minus k, yes?
So it's just x again, not x squared.
It cannot be x squared. It cannot be 2x. It's just x.
Can it be x plus 3?
It can. And our next example is like that. It has to be x with a number. So what we're going to do is we're going to find what that k value is. We're going to find k. And to find k, if you take what we're dividing by, x minus 3, and you set it equal to 0, and you solve for x, it will tell you what the k value is. It's going to be the k value if you solve this. So what do I do to solve that? Add 3. So we get x is 3. That's going to be our k value right there. Now, watch what I'm doing first, because you're not going to know how much space this is going to take up. I'm going to show you how to do it, then you just copy it down on your paper. But you're not going to know how much space to take up until you've seen me do the whole thing. We are going to draw this vertical line and then this horizontal line, and you're going to put your k value by the vertical line. Then from there, you're going to take all of your coefficients from what you're dividing. You're going to take all of your coefficients, including values for x that might be missing. We're going to put all of the coefficients in line with the 3. So the very first coefficient, what's our leading coefficient? -1. That's x cubed. Our x squared is 4. What's our x?
0.
All right, that one's missing, so you have to put that 0 there, just like you did for long division. And then our last coefficient, the constant by itself, is 9. Then I have a space underneath these numbers. So when you're copying this down, just know that there's going to be a space underneath here that we're going to write. We're going to put some stuff in there. So that's how you set it up. You put your k value, vertical line, horizontal line, coefficients. Now the process is you first drop down your leading coefficient all the way down underneath the line. All right, then we multiply -1 times our k value. We're going to multiply those. That answer we put underneath the 4. Right? And then from there, we're going to add together 4 plus -3 and get +1, right? Now we're going to repeat the process we just did. We're going to take this 1 and we're going to multiply it by the 3, and then we're going to put it underneath the next number. And then we're going to add and get a 3. Then we're going to repeat the process. We're going to take that 3 and we're going to multiply it by the k value out there, and we get a 9. Put it underneath that next number, and then do what? Add them. Oh, what color have I not used yet? Now I have no more numbers, so I'm going to stop, and this is actually our remainder. Okay, so to write the final answer, these are the coefficients of the x powers. The -1, the 1, and the 3, those are the coefficients. And then the last number, the 18, is going to be the remainder. This first one is going to be 1 power less than the degree of the original. It's going to be 1 power less than degree of original. So when you look at the original question, the original started with -x to the third. What's this one going to start with? X to the second. And it is going to be a -1 in front of it, but it will be x to the second. It's just always 1 power less. So we're going to write our answer. We're going to use the coefficients. -1, x to the second. Then the next number is 1, so that's positive. I'm going to write plus 1x. Then we've got a 3, and that's positive, so I'm going to write plus, what's my next x after x to the first? Right, so just the 3, it's the constant. Good job. And then after that, how do we write our remainder? Plus, and we write it over the divisor x minus 3. What? So much easier, wasn't it? But it doesn't always work. Should we try another one? Okay. Let's do it. So we have 3x cubed minus 2x squared plus 2x minus 5. We're dividing by x plus 1. We first want to find our k value. So you're going to take what you're dividing by, x plus 1, set it equal to 0. What's our k value? -1. So the k value goes outside of the vertical line, and what goes on the inside? The coefficients. So we've got 3, then what? -2, 2, -5, and we were missing no power, so we didn't need any zeros that time. We bring down the 3 to start, and then we start our process. 3 times -1, -3, add. -5. Then we do it again. -5 times -1, +5, add. 7. Then we do it again. 7 times -1, -7, add, -12, put a box around that. Why do I put a box around it? It's my remainder. So the 3 is going to be the coefficient, the leading coefficient of the answer, but it's going to be 1 power less than the original. So 3 what? X to the second. Minus 5x to the first plus 7. Then you can write plus and then have a -12 over, but you might see us now writing -12 over x plus 1. So you could put plus and then the -12 on top, but you could also just write minus because it's a -12. So you know, I've said this before, everything that we do, you're going to see again and again later. We've learned this division so that we can factor Carter polynomials in the next few sessions. So we really want to get this synthetic division down to save us some time so we don't have to always use one division. And then I was talking with Miss B the other day, she teaches calculus, and she said, yeah, in calculus, everything that we're doing in Algebra 2 is coming back again in calculus. So 2 courses later, things are coming back. She said they just used synthetic and long division the other day to do limits, things like that. So you're going to keep seeing it again and again. There are 6 examples I want you to try some of those. So I'm gonna walk around and I'm gonna check them off. And then we'll have a contest for a little prize for that. There are 6 examples, try some of them.
I would like you to start writing. Done with period. Times 2.
I think you were thinking ahead.
Yeah.
Because it's so easy. I do that all the time. You see me do that. You don't have a mistake, but I know what you did. There's not a mistake in your words, but a mistake that where he's from. I think you looked up at a different question and then wrote that. Yeah, somebody did that in my other class too.
There's a 0.
Hey, remember, if you're trying like number 4, it has an x cubed and it goes straight to an x. And we have to make sure we have all of the powers of x's represented or we're going to have the wrong answer. So make sure you put those zeros down.
That one. Okay, so if you can double check more. I really want you to concentrate on thinking about like, if we have plus negative, you can really think of it, but minus 9 now. I think this is corrected to the 1 way. So we got -9 times 2, which is, so I should say -18 right there. And then add 6.
All right, I'm handing out checks. You looked up here, I think.
Oh, yeah.
I like the third person I've seen do that same thing. Handing out checks. We need some checks. Yep. Okay. Yep. Yep. Did you try number 4? Looks good. Yeah, you should have big numbers. Physics have this one. Did you multiply? Oh no, 19 is. Because this should be negative. Oh. And then that just threw off everything else. After it. okay? No, yeah. Oh, yeah. Wait, more.
Yeah. Your remainder is wrong, so check your last step. It's fine until your last step, which you can and then after. See, it's so easy to make like totally mistakes on this, but. Probably did the same mistake. Zero times 4.
Oh, you did right. I did. What'd you do? I added.
17 times 8.
Lost process.
Okay, so that should be, that should just be plus, yeah.
Okay, keep working on these. If you're done with the 6, I'm gonna put a challenge up in a moment, and I have a reward for the challenge. You can get the challenge ones. But if you're waiting for those challenge questions, you can work on the factoring review in the meantime, because that factoring review is really important before we start our next lesson on Friday.
Yep. And then that one, these are both negative. So you're using, well, but we're not subtracting, we're adding them.
Yeah.
Yeah. 4. Oh, these are both negative. So that should be negative. Which one's going to multiply a negative, and these one is minus 80. Everything else is fine.
Minus 14 over standard minus x squared plus x plus 18.
Oh, wait.
Plus 4 over.
You're having a negative from this should be a negative 1 here in the original. So everything after that's wrong.
8 times 2 is 36. 36 plus 4 is 4.
That's right.
Okay. Yeah.
Got it, got it. Do them all? This one.
And then so this one is done. I don't need to write for F about it.
And this should be plus 1. Because you're doing negative 1. So after that.
What did you do?
Okay, so if there's 0, you don't.
He's good. I'm on my 8.
I could be right. I'm doing it wrong.
Because you just had an XS2. All right, you guys, after this, we'll take a brain break. So if you haven't done all 6 of them, make sure you turn the page. There's 2 on the other page.
What is it?
Right? It was, but what do you do when there's a 0? 3 remainder. Don't count.
Yeah, negative 58 over. Yeah. So it's not a remainder 4 6.
For 6, you should write down the original. This is a negative. So after that. Well, 0 times. This is a negative.
So what do you guys think? Is it easy to maybe make a silly mistake on this stuff?
Yeah.
Like 4 plus 0 is 4 plus 0 is it's so easy to make silly mistakes on these. Okay, the last one is not correct. Because 0 times 4 is... Yeah, 1, 2, 2. I'm looking at 1, 4, 2.
When you don't have a remainder, you just write it.
Yeah.
You get right.
Alright, I'm gonna put up a few of the answers. I'm coming. I'll put up a few of the answers because I have some of the same questions. You guys are doing a really good job about figuring out it's how you write your answer for number 6. You guys are doing a really good job about figuring it out, but I want to make sure everybody knows how to write it. So if there's an error, you have to actually write it. You know, has a small mistake in the last term, just a remainder. I'll put up my guys when you figure out what's
2x squared minus 6x plus 18,
but
then minus 184x plus 30.
It should be a plus. All right, let me put some answers out. Then we'll try some challenge questions for prizes. So 3 should have x squared minus x minus 9. You know what? I totally let it record this entire time. Fast forward on that part. Yeah, right. Minus 12 over x minus 2. Some of you put plus negative 12, and that's totally fine also. Number 4, you should have 2x squared minus 6x plus 17 minus 58 over x plus 3. All right. Number 5, x minus 8 minus 14 over x minus 2. And then when you get to number 6, this is the one that didn't have a remainder, or the remainder was 0. So if you have a remainder that is 0, x squared plus 2x plus 2, don't write it. If there's something that comes up as 0, don't write it. It's not there. Okay? Did I do the last 2 answers?
Yes.
I got it right. Okay. Whoop, there's the challenge. So. Oh, look at Here's the last 2 answers. We should have 2x squared minus 6x plus 18 minus 108 over x plus 3. And then the last one, 2x cubed minus 3x squared minus x plus 4 over x minus 4. So do any questions before we try the challenges? Okay. So the challenges are not in there. You just have to write it somewhere. I believe there's nothing on the back. You can write on the back. So the challenges, have something special about them. You can get 2 checks. I have all this Halloween candy that I would like to give you. 2 checks. Okay? There's 2 challenges, so 2 checks. But do not make silly mistakes, because if you get it wrong the first time, you don't get the candy, okay? So make sure you're right before you get your check. Huh? No, I will, but kinda. I'm not putting a timer on, if that's what you're asking. Okay, the first one, and we're doing this by synthetic division, so you gotta kind of think about it. The first one is 4x cubed minus 6x squared plus 2x minus 9 divided by x. You gotta think about it. Oh, and if somebody says it out loud, then nobody gets the candy, so. You have to do synthetic division. I mean, there are other ways of doing these, but I just want to see if you can do it by synthetic division, that's all. And then the second one is x to the 4th minus 2x cubed plus 5x squared minus 9x divided by x minus 1. Yeah, if you want the prize. Thank you. He was here before you got here. I think you guys did a good job. I would definitely reward that behavior today for sure. I'll bring you something to reward for you. Maybe the Monday or no. What do you think? I'll bake you like cupcakes or something.
A what?
Like a bake cupcakes or something.
Oh,
Good. Allergies? Allergies?
yeah.
Bananas.
I'm not making banana. That's a big racist thing ever. That's one. Other allergies for real? Oh, don't worry, I won't do strawberries. No strawberries, no bananas.
Why not strawberries?
We have a bunch of strawberries, that problem.
No, I said I'm not doing strawberries.
Oh
Oh, you're talking about everything. And I'm not doing bananas because they're disgusting.
Bananas are
I'm just kidding, they're really healthy. You should totally eat bananas.
And they're good for your body. Because I'm allergic to that.
Don't eat bananas. Alright, for real though, you gotta get 2 checks. And then I got this whole bag of candy that I would love to give you. And then, if you don't want to do the challenge, then work on the factoring review worksheet. You don't want to do that. But it's a challenge, so I'm not going to tell you right now.
Oh my gosh. That's kind of fun.
But I mean, obviously, I will tell you before.
It's like in the middle of a test, like.
Right, can you teach me how to do this through the test? Because I can do that through the last. What? Are you? Yeah. Are you ready?
I just checked my allergy.
You could get one then the other.
I didn't know if
When you first set it up.
Stop looking at my stuff.
Alright, let's see, we got a second contender for candy, here we go.
I think if one person gets all the right, they'll be followed.
You get the whole bag? Uh-oh.
I'm just not. Yeah, no more candy.
It's a bag of candy.
Here goes Jake.
I just don't know about you.
Go back and look at him.
I know it.
Stop looking at my stuff. That's cheating.
Alright,
My body's shaking.
do not give out answers, because nobody gets.
Oh.
Yeah. you can't cheat.
Oh yeah, it's from mine. I can pull out straight.
First one, you must have made it so sick. Second one, there was like a challenge to it that you missed. It did, actually. I don't want the CSC direction. No, it's just like you have all of these, right? You and I. So these are challenges because, like, the first one, I don't think any of your homework questions look like the first one. So if you don't get the first one, I'm not worried about it. The second one, homework might look like you are closer.
I put zeros tomorrow.
I wrote it down wrong. I have the entire bag.
No, you do not.
Oh my God, I've never seen so many visions.
Who's ready? Who's ready? And if you are done and you are waiting to go on, remember, we have a factoring review that you can work on. The factoring review is going to take you way longer than any of the synthetic division stuff, so work on it when you can. Yeah, it is part of your Look at them. What?
I want to check the breakdown. Okay. No, you're right. They're like another 2,000. It's just minus 5 out of 6. Or you can just plus 1.
That one's right. You're right. The candy's on the chair there. It's on the right.
No, you have to do.
Can I reteach back?
You have to add a 0.
Not right this second.
Because after X the first comes X and is 0. Right?
Wait, only candy. No, you don't, man. I thought you could candy. No idea.
Am I checking? Did you check that?
That sounded so sad.
Next is like an puppy.
Fail? No, not for candy. No second chance for candy, sorry. Who else wants to check their first check? Who else wants their first check?
No, I know what I did wrong.
Oh. Last chance? Last chance? Alright, you ready? I'm very surprised you guys didn't catch on question 2. The 0 was missing.
But I thought you wanted to put if it was with an X.
Okay, so there is an X. There is an X in the constant term. It's X to the 0. So when you do number 2, and you have your 1 out here, you should have 1, -2, 5, -9, and 0. So some of you, that was the problem. And then some of you just make silly mistakes, but what do we do? For that one, if you made this plus 0, then it would be in that correct form. So that would be a 0 out here. You have 4, -6, 2, -9. And when you do things like bring down 4 and multiply by 0, it just becomes 0. 0. 0. And then you write all your answers. For this one, you get 4x squared minus 6x plus 2 minus 9 over x. Oh, you don't need plus 0. All right. Okay. Good job. I'm going to play a round of the dice game.
Yeah.
We can stand up before we finish up our notes. Where is my candy? Somebody steal it? Oh no, there it is.
Somebody robbed. I'm gonna stay the same number again. See if I can.
How about I'm still recording? I keep forgetting I'm still recording. So, what we're going to do is we're going to evaluate a function at a given value x equals -4. We have already learned one way of doing this. We've already done one way in the same chapter. So I'm going to review the old way, then I'm going to show you the new way. The old way would be doing like f of -4 equals 5 times -4 cubed minus parenthesis -4 squared plus 13 times -4 plus 29. That would be the old way. And then what would we do from here to find the value at -4? You could type it into your calculator. Unless your calculator's dead, then what would you have to do first? If you're or if you were on the non-calculator part of the ACT, what would you have to do at that point? What? There's a non-calculator part? Yep. You need to do order operations, but what's going to come first?
Exponent.
We're going to do the exponent. That cubed is going to go on what number? Just the -4. Then we multiply by 5. So you'd have to go through that whole process. All right, who has the answer for me?
Oh, I was just using division. How is this using division?
We haven't showed you.
Oh, okay.
I haven't showed you the new part yet. This is the old way. This is the old way. Here's the old way. I haven't showed you the new way yet. But we just type it in our calculator. Santoro, what'd you get?
I got 61.
I got -307.
Oh, you didn't do it? Okay.
359.
Yeah,
Negative 359. Okay. Now what we're going to do is we're going to discover the other way of doing it. You're going to discover the other way of doing it by using synthetic division. So this is called the remainder theorem, and you'll see why as soon as we do it. We're going to use x equals -4. That's our k value because it already says x equals. So we put -4, and we draw the vertical and horizontal line. Then we put in our coefficients, 5, -1, 13, 29. You do it. You do it. Do your synthetic division, what we just learned. Your calculator. Did you get it?
Alpha y equals.
Okay, so what you do is you bring down the 5, multiply -20, add -21, multiply positive 84, add 97, multiply -3, is it 88? Thank you. 88, add -359.
Whoa.
The remainder is the answer. So this is called the remainder theorem because it says if you plug in a value, the remainder is the value of that function. That's it. So my answer would be -359. You do not write the whole function again because it's only asking for the value. You won't write the whole function again when it's asking for the value. So that's just the answer. Can you try the student example, the next one? Or two, actually there's two of them. Next two, and as soon as you have 2 checks, then you can start on your assignment. So I'll come around and check away.